Good morning. So, in some of my posts, anybody who actually reads my posts anywhere, I talk about in the evolution in neutron decay cosmology. The premise is basically you have the neutrons that are in the neutronium that form a neutron star, and then this neutron, when it contacts the event horizon, becomes the vacuum energy, because the vacuum energy is essentially like a layer of neutrons, a plane of neutronium underneath everything. So this decays, the neutron decays, becomes a proton and an electron. I put the electron all over because, they spread around. Where's the protons located? And that a neutron is a proton, basically, that has had its electron shoved back inside itself. This is one mass of the proton is 1/2 pi Planck length photon trapped over its own gravity. This convolution in space, this contraction in space, this convergence in space causes the positive charge. The negative charge is like a little pocket of inflow divergence. Positive charge is caused by convergence in our side of the universe. Okay, so it decayed, it became a proton and an electron, which is hydrogen. And then this hydrogen follows usual evolution. But I usually skip over because in my talks, I talk about this amorphous atomic hydrogen. This is atomic hydrogen, there's no neutron. There's not deuterium, it's not tritium, it's atomic hydrogen. But initially, when the neutron decays, people will even say, it's like, well, it doesn't decay into hydrogen, it decays into a proton, an electron, over here someplace or something, and a neutrino. And we leave out our anti-neutrino. And we leave out the neutrino because I consider them catalytic particles pretty much. They attach charge to masses or remove charge from masses. They're always associated with this kind of process. So anti-neutrinos away, takes charge off, neutrino puts charge on. And so let's draw it this way, where it's just weird and jumbled up. So what's over here? Well, a proton doesn't want to be here, but maybe an electron would be here. And what I talk about is that initially amorphous atomic hydrogen is this decayed neutron. So you have a proton and you have an electron. You have mass. But because the electron is not in orbital, it's not really hydrogen, therefore it can't scintillate, it cannot emit or absorb photons. It's going to be totally invisible. Why wouldn't it be invisible? It's not a unit yet. And this is what I just suggest happens. The neutron decays. Initially, in the deep voids and other places, it becomes a proton, an electron, and a neutrino, and this is just like a soup. Over time, at the edges of filaments where we start to see matter, is where these electrons finally start to stabilize and get their orbits over the protons. And now they can emit photons. Now they can absorb photons. But in this earlier stage, there is no way of even knowing there's anything there. There's no interaction with light. There's only interaction with mass. And there's a charge, but we can't really see the charge because we're not doing, from what I understand, polarization analyses of everything, like profound polarization analyses. I really think in a telescope, and if there's any people who are related. Okay. Here's your field. Okay, whatever you're looking at, here's some galaxy. Spiral galaxy, a little bit edge on. Okay, when we're looking at this, what we need to have is like a polarization filter if we could. And then we just take a photograph, I guess. Take a photograph, take a photograph, take a photograph. It has to be done this way. There's no really truth of continuality, but scroll through the polarizations. Because I think that could give us clues as to like a more, enhance our 3D perception of what the heck is going on in all the places where it's not scintillation. Okay, because the only things we can see are things that make photons. If there's no photons, then we're, stuck. Dark matter. What is dark matter? Dark matter is decayed neutrons. Neutron decays. Boop. Proton over here. Proton over here. Neutrino goes shooting off someplace. Who knows? In time, as it gets denser, as it gets near a filament, this happens. And now we have light. This is the evolution. This whole Big Bang thing is just a skew in perspective. What we're observing as the early Big Bang is neutron decay process, just warped because of the gravity of the universe so badly that it's really confusing. Anyways, neutron decay cosmology proposition.